chemical weathering processes. Chemical weathering plays a pivotal role in shaping karst topography by influencing the dissolution of soluble rocks, primarily limestone, which forms the foundation of these landscapes. This process occurs when acidic water, often enriched with carbon dioxide from the atmosphere and soil, seeps into the cracks in the limestone, leading to the gradual breakdown of rock into dissolved minerals and secondary deposits. As chemical reactions facilitate this erosion, distinct landforms such as sinkholes, caves and underground rivers emerge, showcasing the dynamic interplay between water and geology. The depiction of these processes illustrates essential features like swallow holes and caverns resulting from chemical weathering, providing a visual complement to the text's exploration of these transformative dynamics. Chemical weathering, mostly solution and carbonation, is the most important denudational tool which aids in the formation of karst topography. Biological and physical weathering are passive contributors. Influence of climate on karst formation. Climate plays a pivotal role in the formation and evolution of the karst landscapes, as variations in the temperature and precipitation directly influence both the chemical weathering of the limestone and groundwater dynamics. The region must have least to moderate rainfall. It is significant that all karst regions are in areas of moderate to abundant rainfall. In humid areas, the increased rainfall benefits the dissolution process, allowing carbonic acid in the rainwater to more effectively erode the soluble rock, leading to the development of features like sinkholes and cave systems. Conversely, in arid climates, there is reduced erosion and the preservation of distinctive rock where evaporation rates surpass precipitation. The formation of karst is markedly different formations. The identification of these processes can be illustrated effectively through detailed diagrams of karst landscapes which display various geological features including sinkholes and caverns attributable to the climate. Understanding the intricate relationship between climate and karst formation is essential in today's time for comprehending the broader aspects of geological and environmental science. Now let's understand what are the conditions essential for development of the karst topography. To summarize, the following 4 conditions are prerequisites for the formation of karst topography. Firstly, there must be presence of near surface soluble rock, which is preferably limestone. The soluble rock must be highly jointed, dense and thinly bedded. Permeability favored by numerous joints and bedding planes is favorable. Existence of entrenched valleys below uplands underlain by soluble and well-jointed rocks. Fourthly, the region must receive a considerable amount of rainfall, at least moderate amount. Now comes the question, what is deposition? It is one of the phases in which denudation of the earth's surface is carried out. Depositional landforms are formed due to the denudation of the earth's surface, with deposition being the most main important contributor to the resultant landform, but with weathering, erosion and transportation also being the passive factors. Let's understand the types of depositional landforms in the karst regions. In karst regions, various depositional landforms are formed from the intricate interplay of water and soluble rocks, particularly limestone. Among the most prominent features in the depositional landforms are stalactites and stalagmites, which form in caves as droplets of mineral-rich water deposit calcium carbonate over time. The processes involved in these formations significantly contribute to the unique landscape associated with karst topography. Deposits in the karstic caves are collectively called speleothems. These are crystalline deposits of calcium carbonate which are formed as a result of precipitation from dilute aqueous solutions entering the cave, typically as drips from the roof. This is how the shapes are formed in cave interiors, and it also results in spectacular columns and flow stones. as stalactites and stalagmites merge. Additionally, surface forms like sinkholes and dolines contribute to the overall morphogenesis of the karst landscapes as a result of the ongoing denudational processes. These various landforms showcase the complexity and beauty inherent in the karst topography. Stalagmites and their formation. Stalagmites are fascinating formations in the karst topography which arise from in the caves when deposition of dripping water occurs. The process begins when water containing dissolved carbonate minerals seeps through cracks in the limestone ceiling, and when these land droplets fall to the cave floor, the reduction in the temperature and pressure induces the precipitation of the calcite, gradually building up stalagmites from the ground upward. Thus, slowly yet continuously growth is vividly illustrated in the cave environment, showcasing how stalagmites intertwine with other geological features. According to geological studies, stalagmites are formed by water dripping from the ceiling. When the drop lands, calcite deposited and a stalagmite grows upwards. The integration of mineral deposits and water dynamics underscores the interdependent relationship between geological processes and environment, especially the stunning aesthetics of the subterranean landscapes. Ultimately, stalagmites not only enhance the beauty of the caves, but they also serve as a significant indicator of the environmental history which is recorded in their layered formations.